Okay, in this session, we're gonna review a previously tested problem in real AP Calculus exam. Here's the problem. Consider the curve defined by the implicit equation y to the third minus xy equals to 2. It can be shown that the first derivative is dy with respect to x equals to y over 3y squared minus x. And question A is asking you to write an equation for the line tangent to the curve at the point negative 1, 1. Okay, so that it's acting for the equation for the tangent line. So actually, question A is asking you the slope. So it's asking you the slope at the point of tangency. You should know that the slope is equal to the derivative of y with respect to x, which is already been given by the problem, y over 3y squared minus x. So let's say that the equation of the tangent line, it is y equals to ax plus b, where a is the slope of the tangent line, b is the y-intercept. At the point of tangency, which is negative 1, 1, we just substitute the value into the expression of dy with respect to x already be given. So this is y over 3 times y squared minus negative 1. It equals to 1/4. And we just substitute that back to the tangent lines expression. So we have the y, left-hand side of y, it's 1 equals to a, the slope equals to 1/4 times x, it's negative 1 at the point of tangency, plus b. So easily we solve b equals to 5/4. Good. And therefore, final answer for the questions asking for the equation of the tangent line can be expressed as y equals to the 1/4 times x plus the y-intercept 5/4. That's it. Now we have the second question. Okay, ask us to find the coordinates of all points on the curve where the tangent line is vertical. So this is asking you question B is asking you the slope vertical. Okay, at the point of tangency. So you should realize that for the slope of the tangent line to be vertical, you should have dy with respect to x at the point of tangency as undefined. Or you can say the reciprocal of dy with respect to x, which is dx with respect to y, equals to 0, so that the slope of the tangent line would be vertical. And dy dx is already been given. Dy dx given as y over 3y squared minus x. 3y squared minus x. And therefore the reciprocal, which is dx with respect to y, it's just 3y squared minus x over y. It should equals to 0. And therefore we have the constraint. We have a constraint to the point of tangency. Constraint to the point of tangency as 3y squared minus x equals to 0. So dx with respect to dy would equal to 0. Or you can say dy with respect to dx is undefined, because in this case, the denominator of dy with respect to x is 0. Okay, so we can easily solve that for x equals to 3y squared. And of course, we also have the constraint as this point of tangency is still on the curve. So we still have the curve equation. The curve equation, okay, is given as y to the third minus xy. Okay, it's given by the implicit equation y to the third minus xy equals to 2. Okay, given by the implicit equation. So we just substitute that x equals to 3y squared into the curve equation, as this is also a constraint to the point of tangency. So we'll have the left-hand side, y to the third minus 3y squared times y equals to 2. Okay, and the left-hand side is just negative 2, y to the third, right-hand side for sure, 2. So we solve that y to the third equals to negative 1, which is y equals to negative 1. Good. And because x is equal to 3y squared, so it's 3 times negative 1 squared equals to 3. Good. Therefore, the coordinates of the point at tangency where the tangent line is vertical, okay, as we solved, it's just 3 and negative 1. Okay, this is the final answer for question B. Good. Good. Now we have the last question. Question C. Okay, ask you to evaluate the secondary derivative of y with respect to x at the point on the curve where x equals to negative 1 and y equals to common 1. So this is question C. Ask you to solve the secondary derivative of y with respect to x. And we have the dy with respect to x. Okay, this one is given by the problem as y over 3y squared minus x. So you can directly apply the quotient rule. apply the quotient rule. Okay, so let's try this approach. And then the secondary derivative of y with respect to x can be directly solved as the derivative of the numerator, which is dy with respect to x, times the denominator, 3y squared minus x, minus the numerator, y, times the derivative of the denominator, 3y squared minus x with respect to x, and then over the denominator, which is 3y squared minus x squared. Good. Okay, and we notice that what we know that this one. So we can have the 3y squared minus x expressed as y over dy with respect to x. Okay, this coming from the expression of dy with respect to x given by the problem. So we can use this to simplify the expression of the second derivative of y with respect to x. So let's do it. So now we have the secondary derivative of y with respect to x. We try to simplify by substituting the 3y squared minus x with y over dy with respect to x. Okay, and for this one, for minus y times, okay, this one we're gonna solve the derivative of this one, so we're gonna apply the chain rule. So the derivative of this one is actually 3 times 2y times dy with respect to x minus alpha of x, derivative of x with respect to x is just 1. Okay, derivative right 1 over. We also substitute the denominator, the 3y squared minus x with y over dy with respect to dx squared. Good. And we know that the numerator, dy with respect to x, dy with respect to dx, can be cancelled. So the numerator is actually y minus 6y squared times dy with respect to x plus y. And of course, this is just 2y for the numerator. And also the denominator is y squared. Let me write it in blue. It's y squared over dy with respect to dx squared. So we continue to simplify the expression by multiplying both the numerator and denominator with this one, with the dy with respect to x squared. So we simplify the expression of secondary derivative of y with respect to x as we multiply the numerator by dy with respect to x squared. Okay, multiplied by this one, and then times this one, 2y minus 6y squared dy with respect to x. And also denominator multiplied by this one as well. So it would simply be y squared. And therefore it equals to 2y times dy with respect to x squared minus 6y squared times dy with respect to x to the third over y squared. And it could be further simplified by canceling the y. So this is y, this is 2, and this is 6y. So eventually we have the secondary derivative y with respect to x as 2 dy with respect to x squared minus 6y dy with respect to x to the third over y. Okay, but you can also, you can also solve the secondary derivative of y with respect to x by doing what? By doing the implicit differentiation. Okay, so let's try this one. Since dy with respect to dx is already be given as y over 3y squared minus x, we can multiply each hand side by this one, by this denominator, 3y squared minus x. So the left hand side would be 3y squared minus x times dy with respect to x equals to y. And then we take the differentiation operator to each hand side. And we will have the derivative of 3y squared minus x times dy with respect to x. Okay, which is the left hand side. The derivative of the left hand side with respect to x. And of course, the right hand side is just the derivative of y with respect to x. Okay, though here clearly we're gonna apply the Chen rule again. But prior to that, we notice this is a product expression. Okay, it's 3 y squared minus x multiplied by dy with respect to x. So we should apply here, in here, the product rule. So we have the derivative of the first term. This is 3 times 2y times dy with respect to x. Okay, this is actually applying Chen rule minus derivative of x with respect to x is 1 times the second term dy with respect to x. Okay, good. Plus the first term, 3y squared minus x times the derivative of the second term, which is the secondary derivative of y with respect to x. So this is the left-hand side. After applying the product rule, it equals to dy with respect to x. Good. So clearly here we notice that there's actually a common factor of dy with respect to x here. So we simplify the equation by keep 3y squared minus x times the secondary derivative of y with respect to x on the left-hand side. And now the right-hand side would be dy with respect to x, the common factor, times 1 plus 1 minus 6y times dy with respect to x. Good. And note that here we can also simplify the 3y squared minus x because dy d with respect to x is given by y over 3y squared minus x. So we can substitute 3y squared minus x by y over, okay, dy with respect to x. So the left-hand side would be y over dy with respect to x times the secondary derivative of y with respect to x. And the right-hand side would be 2 times dy with respect to x minus 6y times dy with respect to x squared. So we multiply both hand side by the reciprocal of this one, y over dy with respect to x. We multiply both hand side by the reciprocal of this one. So the left hand side would be just the secondary derivative of y over with respect to x, and it would equal to 2 times dy with respect to x squared minus 6y times dy with respect to x to the third and over y. Okay, so we note that this expression, simplified expression of secondary derivative of y to x is actually the same. It's actually the same of compared with we doing by directly taking the quotient rule approach. It's actually the same as 2 times dy with respect to x squared minus 6y times dy with respect to x to the third and over y. Okay, so either approach is fine. You can reach the same expression for the secondary derivative of y with respect to x. So what's the value? What's the value of secondary derivative of y with respect to x at point negative 1, comma 1. So actually we did that in the question A. The derivative of y with respect to x at the point is just as given by the problem. So 1/3 times 1 squared minus -1 equals to 1/4. Okay, and of course, at the point y equals to 1, 1. So we just substitute the value into the expression of secondary derivative of y with respect to x. So it should equals to 2 times 1/4 squared minus 6 times 1 times 1/4 to the third. And it's over 1. Okay. So this is 2/16 minus 6/64. And clearly the common denominator is 64. Numerator is 8 minus 6 equals to 1/32. Okay, so we have the final answer for the question C as the secondary derivative of y with respect to x at point -1, equals to 1/32. And by the way, actually, though the expression of dy with respect to x is given already by the problem, so actually you can do that. You can solve that dy with respect to x by implicit differentiation by your own, because of what? Because the curve equation is given by the implicit equation as y to the third minus xy equals to 2. So similarly, you just take the differentiation operator to both hand side. So you will have the derivative of y to the third minus xy with respect to x equals to, this is constant. So the derivative of the right hand side with respect to x is just 0. And in this case, by applying chain rule, the derivative of this one is 3y squared times dy with respect to x. And this one is a product expression. So this is minus what? Minus the derivative of the first term, which is 1, times the second term y, plus the first term times the derivatives of the second term with respect to x. It should equals to 0. Okay. So we move the y to the right hand side, and we take the common factor of dy with respect to dx. Okay, so it's 3y squared minus x, good, on the left hand side. And then we just divide the both hand side by the 3y squared minus x, and we will have dy dx equals to y over 3y squared minus x. Okay, it's the same as given by the problem. Good. So let's see what's tested in the problem. We are tested the slope, okay, of the tangent line at the point of tangency. It should equal to the dy with respect to x. And we also been tested the slope of the tangent line to be vertical. And we should have the dy with respect to dx undefined, or the reciprocal, the dx with respect to y equals to 0. Okay. And we also tested the quotient rule. If you directly solve the secondary derivative of y with respect to x. And of course, we have tested chain rule. Okay, when we were trying to get the derivative of 3y squared. Okay, and we also tested the product rule by the implicit differentiation approach. So these are all core principles of calculus, and they are very frequently tested in AP Calculus exam, and you are expected to be very familiar with them. Okay. Okay, good. So that's it for today's session, and see you next time.